everyone, Alex is here.
Have you ever written code that comes messy or copied functions and in general find it hard to understand some connects between your functions and...
Yeah, all of us have been going through this way, and that's okay. Most of that it calls like functionality paradigm, and you know what? There is one way to solve that. One of the ways. It's OOP, Object Orientation Programming. But what's that? Is it a magic? It's not. And also, it has downsides that you should to know. And I'm speaking, a lot of people are speaking about that as something hard to understand and all these things. Today, I will try my best to do whatever I can so you'll understand everything easy. You'll know its downsides, when it is used, and what is the future of our object-oriented programming. So let's start. Firstly, let's talk about which concepts OOP has. So in general, they have just 4 of them. And before going to them, I just want you to know that there is a story, and quite short one. For example, for one of the developers of this concept, there is a long story short. So there was Alan Kay, Ole John Doll, and Kristen Nygaard.
Yes, I remember.
So they have been creating this OOP. They haven't done it together. So if you want to discover these things, you can ask AI or go to Google to discover the story about that. But in general, once upon a time, for the Kristen Nygaard, he has been asked, "What are you doing?" And he told that I'm doing OOP. And in general, he was trying to tell the people that biology is one of the fundamental things for OOP. Why biology? Because one of the most complex things that are in the world is the human and in general biology, because it's so complex. All the neurons, all the blood, for example, it is connected with all of your system, and it nearly can't be working without one of the parts, or it can work and the system of, for example, humans body can understand how it can work. So in general, that's the idea of OOP. So we are trying to take this human being and put it in our system. So in general, we have just 4 principles. It's encapsulation, inheriting, abstract, and polymorphism. Yeah, 4 of them. And you need to understand how does they work. Encapsulation is like you're taking a capsule and put it in the ground. So no one should have connection to that. No one can change that. That's first idea. Inheriting. When you have children that is inheriting all the parents' properties, values, etc. That's the second idea. Polymorphism. It's the thing when it's a biology thing. So in the general, polymorphism is when you can, for example, eat like a human, but for example, some micro viruses, for example, or let it be a fly, or let it be tiger, all of them are eaten in the different way. Food has been transformed in the different way, but it is transformed. All of us are eating, but in general, we are doing that in the different way. This is polymorphism. When you have one thing that is, for example, eating, but this eating process is different for each of your objects. And we'll speak about that. So let's go further. Abstraction is when you want to tell something that you, for example, you're telling the person you should do something like my example, but it shouldn't be as that. So I have written you some instructions what you should change or what should be there. And let's start with all of these ideas exactly in our code. So here you see the Python example, and here we see all of them concepts that we should have. So firstly, abstract. For Python, you should import that. You can discover why and all the things. And you see the class that is animal. It is our abstract. What it does for us? So firstly, it can help us to understand what we should write. You see here an abstract method. Mostly of all the programming languages have their abstract methods, and that's easy for us to understand which method specifically should be in our inherited class. We'll talk about that a little bit later. So in general, what does it tell for us? This method should be in all of our inherited objects, in dog, in cat. If it won't be there, there'll be an error that, sorry, you should provide speak method for your inherited objects. So, what is abstract? Abstract, when we're telling for our inherited objects, you should have such property or method. That's it. The next thing, encapsulation. What is that? Is when you have something that shouldn't be changed. For example, as here, we can provide the name for our dog, cat, and etc. And what does it tell for us? That this property cannot be changed. For example, you have 3 main colors that dog can understand in your programming realization. And you don't want anyone from your team or anyone from the global community, if your project is open source, to change these values or methods. You just wanted to tell that this thing cannot be changed. That is called encapsulation. When you're saying something cannot be changed, modified, that is encapsulation. That's all. And it's for methods, for properties. I will show you examples in the others programming languages. And then inheriting and polymorphism. So what does inheriting do mostly? Inheriting should be done for gathering some properties. For example, eating. Dogs and cats, all of them can eat. But we don't need to duplicate this code, because there is one of the concepts
for OOP principles. DIY.
Don't repeat yourself. No, the DIY is something from the other thing. Don't repeat yourself. Right, not DIY. Sorry. And this thing, for example, eat method, it will be working the same way here and here. And when you will call dog object or cat object, you can ask eat method that will work mostly the same way as it was written here in parent object. That's how it works. So you just need to change it here, for example, like here, like that, and it will be working the same way in dog and cat. That's how it works. And let's go to the last one, polymorphism. When I'm telling to you that something is for each of our objects, but it's unique realization. So it is very great to combine it with abstract. So you're taking an abstract method that is, for example, necessary, speak, and for each of your property, you're rewriting it, you're modifying that. That is polymorphism. When you say that this property will be renamed or modified to the another one. For example, speak. Speak in dog is with roof and with cat is meow. That is how it works. So when we are working with that, we're just should tell that polymorphism will modify the parent value. That's all. And you can use it without abstraction. So in general, it won't require you to change this value. For example, you can modify here it we can modify it method for doc specially. For example, it will work, it will call polymorphism. That's an idea. And you can work with abstract, so like here, speak, and then polymorphism, you're editing that. But mostly you cannot work with abstract without polymorphism. Because if you won't write polymorphism for your speak value, you'll have error. That's an idea. So that's 4 ideas that you should know. If you have any questions, please write down below. Well, I'll try my best to tell you the most that I can. Our community can help you. And let's check how does it work in TypeScript, Java, C++, and C#. That's good. So we can see here TypeScript. So as you can understand, this is working in the same way. We have here, you can see here abstract class. You can see here encapsulation. So our variable is protected. Here you can see that name is protected, so it cannot be changed. Also we have here our it method. We can see here inheriting and polymorphism. Yes, it is done in the different way with Python, and that's okay. That is the difference between these programming languages, but in general that's the same thing. So it extends our animal and gives us some more possibilities. For example, to work with it. Okay, let's go with Java. Java, the same thing. Class, encapsulation. Yeah, there is no more such mistakes. Encapsulation. So we have protection here, and then we have public methods that can be changed. For example, it, speak. This is another public method. You will discover Java and know why they have the same name, and that's how it works. So let's go further for our so we have here a little bit big code, but it's the same thing. So we have public abstract class, the same thing, our main one that we are held in our dog and cat. We're encapsulating that. We're override our method speak because it's abstract method. Public string speak. We have protected property name. It is encapsulation, and we have our it method that is inherited by our dog and cat. They can use that, and we shouldn't write the same it for each of these classes. And the last one, our C++, the same class, encapsulation with protected property, public methods that can be taken and changed. We have our virtual, means abstract, in this way, method, speak, that is required to be overridden. You can see that here. Same thing. And also inheriting, where for class dog we're inheriting public animal. We're changing that once more with polymorphism. And all of that, all of these things, they're for all the programming languages that you know. It will work in the same way. I hope that now you understand more about these 4 concepts: encapsulation, inheriting, abstract, and polymorphism. Yeah, so let's go further. What is advantages for our OOP? So as you can see, there is more structure and modular code. And what it can help us? Firstly, when you're working in a big team or in a scalable big project, you can, for example, take the new person for your company and you're telling that you're creating the doc object. For example, you're creating a game. And this person, you know that he can just inherit animal class and he'll know everything he or she should know for this property, which methods could be used, why, what is protected, what's not. And it's only one example how it can be scalable, it can be reusable. With a functional principle, you cannot just take method and reuse it in any other files. That's not always this thing how it works. You can make utils folder and export the thing in some way. Yes, it could be. But OP is the easiest way to do that. It's the easiest and more understandable. And when you understand the OP, you understand that mostly in all the programming languages, they're really the same. This is one of the most interesting things that no one will tell you, because you can see, I have shown you 5 programming languages. There are not a lot of specialists who know all of them at once, but know only one, for example. And you can understand approximately how it will work in other programming languages. Magic? Not really. That's an idea of that. That's an idea. But also, that's got downsides. Really, something that you should understand. Firstly, it's complex for beginners. And that's true. It won't be as easy as just a function. You should understand this inheriting. You should understand why it'll do that. In general, why it's so complex and in which specific really code it will work. But that will work. It will work in a big teams. When you're working with the code, that should be really good scalable, because it won't be it's just functional programming. Also, it's easy to over-engineer that. What does it mean? It means that you can just write so many things that could be overlaid that in some way it will make the problem, and you will
try to find in which class there was a problem inheriting or method that was used in the another one that was overwritten, then one more time, and
sometimes it could be over-engineered. And for not doing that, mostly what I like to tell you, you should just have a goal of solving the problem. And when you try to solve the easier, the fastest way, that you won't over-engineer that. Because over-engineering, when you're trying to make the best, refactoring the best, what it can be, the best performance, and etc. And honestly speaking, that mostly cannot be done because it's really complex. It's really complex to work with all of such examples. Okay, and also it's not ideal for functional style tasks and scripts, and not all of things should be worked with OP. For example, AI. Mostly you shouldn't and you won't use OP for working with AI, because mostly it's functional style task, because you should just create a model that shouldn't be taking a lot of inheritings with your OP. Maybe there are some companies that are using that. Please write down below your experience with working with OP and AI programming, and I mean for creating models for AI, not just using the AI. No, I mean creating AI. I think that most of the people will say that they're using functional style for creating their models. That's the truth, because this is the specific of the task, and sometimes you cannot do anything else. And of course, there will be most of the time a function style task that you can do in a small companies, or even in a big company. There will be a task that should be done only with functional style programming, because if you'll take OP, it will be just a lot of time, and it will be like there will be no clue for that. So But mostly you shouldn't worry about that. Your manager or your or just the specific of the task will tell you what to use. And mostly you should discover how to work with OOP. When you're starting your project, please don't use OOP. Just try to use maximum functionality styling. Then you will understand when to use OOP, because it will be so big that, and you'll have so many duplicated codes that you'll understand that, oh, I should have OOP here right now. And you'll really redone that, and that's okay. And when you go to the big company, to the Mac, to the big tech, you instantly see the working with OOP, most of the all. And you understand in that way why you're using that. So everything should have their thing. Yeah. And the best practice, some of that I wanted to tell you, is solid principle. It's one responsibility per class. It's avoid deep inheritance. And use compositions where it makes more sense. So these practices I will leave you for discover by yourself, so we'll make this video not so long, and you'll try to figure it out by yourself, because it's really important to discover and know a lot of things by you, because a lot of things sometimes couldn't be just felt, there should be experienced. Please remember that. And in general, what is our future? Future for our OOP. You know what? It is like modern languages. They're using mixed paradigms. For example, Python. For example, let it be C++, Julia programming language, Kotlin, Rust. It doesn't really matter which one's more, because most of them they're using mixed paradigms, and the functional programming languages is growing. And OOP, I think, not is growing so much as a functional one, but functional will stay. It will adapt. It won't disappear. And I think in the future we'll have more connections with functional. I think we'll try to mostly combine OOP with our functional programming as much as we could, and it will be a little bit new era of OOP with functional programming. That's my idea. That's my idea. You can think as it will be better for you, but that's just my idea. So, object-oriented programming is a tool, and like any tool, it's important to know when you should use it. Yeah, so don't ignore that. Try to discover that. If you have any questions, write down below. I will try to do my best to help you. Thanks for being here. See you in the next videos.